Okay, so welcome back, class. And so today we're going to talk about translations, specifically vertical translations, and then we're going to talk about horizontal translations. So this is going to involve adding or subtracting a value, okay, a real number from the function, either outside the function or inside the function, and subtracting or adding something to the x value, okay? So this is the last piece of the puzzle for graphing using transformations, okay? So let's start with a couple examples and then we'll go over, okay? So here, well, actually let's go over this first. I think that'd be probably better. So vertical translations, okay? So if you have a given function g, okay, defined by g of x equal to f of x plus some c value where c is a real number, okay? So we're defining g as a function f, and then we're going to add some c number. So a couple bullet points here. One is what this means is for every point xy on the graph of f, there will be a corresponding point, we'll call it x comma y plus c, that's on the graph of g. Okay? So every point on f, there's going to be a corresponding point given by this representation. Okay? So that's what this means. It's for adding some c value. So we're adding c value to y. So if we have some x plus y, xy on f, then if we add c to y, that's going to give us a corresponding point on g. Now the second thing it says here is the graph of g will be the same as the graph of f, but translated c units up if c is positive, or it's going to be translated c units down if c is negative. So what this is saying, so this bullet point here follows from this, is that, which also follows from this, is that, hey, if I add a positive value to a function, that's the same as translating that function up c units. Okay, so in that case, g would be moving f up c units. If c is negative, so in other words, I'm subtracting c, right? So if I'm subtracting c units from f, that would be the same as moving it down c units. So then in that case, g would be a translation down of the function f c units. Okay, and so when you're outside the function, so basically the point that I'm making and that the textbook makes is that if you're adding or subtracting a real number from outside the function, so if you're taking f of x and you're adding or subtracting a number to the function, okay, and you're outside the function, in other words, then that would correspond to moving or translating the graph of f up or translating it down a certain number of units. Okay, so if you're adding, it's moving up. If you're subtracting, it's moving down in the vertical direction. Okay, and so let's look at an example. So let's go back to our absolute value. So there's our absolute value basic function. And so now what I want to do is I want to graph both of these functions. So let's graph g of x. So now g of x is, I'm outside the function, right? So that means what am I going to do? I'm going to subtract 4 from all of the y values. So in other words, I'm taking all of these points and I'm moving them down 4 units. So if I wanted to plot g, I would basically take this point here and move it down 4 units. So that would go down to here. And then this one would go down 4 units, which would put it here. Like so. Okay? And then, of course, this would be translated down 4 units. And so that would go to here. Okay? And so what I would get is something that looks like that. So what I did was, in effect, I took f of x, right? So that's f of x. I took f of x, I moved it down 4 units. Okay? Now, what if I moved it up? What if this was plus? Well, then what I would do is I'd be moving it up 4 units. So it would start here. Okay? And so whenever you're outside the function, if you're adding or subtracting anything from or to the function, it's moving up and down in the vertical direction. Okay? Okay. And so the next time what I'm going to do is I'm going to go through horizontal translations when you move left to right. And that has to deal with when you're inside the function. Okay? And so how is this going to change? Okay, well, let's change this a little bit. So I'm going to change this wording. So this is going to be for horizontal translations. Okay, so now I'm going to change this. Okay, and so I'm just going to change this a little bit. So now I'm going inside the function, right? So now I'm adding c to x, not to the function itself. Okay? So now what I'm going to say is for every point xy that's on the graph of f, there will be a corresponding point, and here it comes. X plus c comma y. That will also be on the graph of G. And so what is it saying? That, well, for the graph of G, in this case here, C, so the graph of G will be the same as the graph of F, but translated C units to the right. If C is positive, right, and it's going to be C units to the left, if C is negative. Okay, so let's go over this one more time, because now, again, remember when I did the video on vertical and horizontal stretching. I said vertical stretching and shrinking is intuitive, what you would think it would be, but the vertical and horizontal, but the horizontal shrinking and stretching is like opposite of what it is for vertical shrinking and stretching. Okay, same holds for translations. Okay, vertical and horizontal translations. If you are outside the function and you add a positive integer or positive real number, then you're moving up. If you subtract a positive real number, then you're moving the graph down. Okay? So, but in the horizontal, it's opposite what you would think. So in this case here, so let's go over it one more time. If a given, for horizontal translations, a given function g is defined by this function, g of x, f of x plus c. Oh, I'm sorry, that's wrong. X minus c. Okay, x minus c. Okay? So x minus c, right? So that means if c, so it says for every point xy on the graph of f, there will be a corresponding point x plus c comma y that's also on the graph of g. And then the second one basically says, hey, the graph of g will be the same as the graph of f, but it's going to be a horizontal translation. So it's going to be translated C units to the right if C is positive, and it's going to be C units to the left if C is negative. So what does that mean? If I subtract off a positive value of C, so if this is x minus a positive value of C, I'm moving to the right. If I'm adding a value of C, so if it's x plus some positive value of C, then I'm moving to the left. Okay? So it's opposite what we were thinking about as far as with vertical. In the vertical direction, if you add a positive number, you're going up. If you subtract a positive number, you're going down. But in horizontal, if you're inside the function, it's opposite. If you subtract a positive number, you're moving to the right. If you add a positive number, you're moving to the left. Okay? So let's see what that looks like. So in here, I have x minus 4. Now, if you take what this is saying, it means that, hey, I'm subtracting off 4, which means I'm moving 4 units to the right. But let's see what that looks like algebraically, okay? So here's where we start, right? So, normally, it's at 0, 0, right? Well, if I want this to be 0 in here, what would x have to be? X would have to be 4. So it means that, hey, in order to be 0, in order for y to be 0, x has to be 4. That means I'm going to have a dot there. So at 4, at x equals 4, y is 0. Okay. Now, what about at x equals 5? When x equals 5, I get 1. So all I'm doing is plotting the points. And when x is 6, it's going to be 2. Right? Now when I go to 3, well what? 3, now I get negative 1, that gives me a positive 1. So I get 3 positive 1. And then 2 is going to give me what? Positive 2. And so look what happened. This got moved 1, 2, 3, 4 units to the right. So I subtracted 4, and I moved 4 units to the right. If this would have been plus 4, it would have moved 4 units to the left. Okay? So you got to make sure you look at what is going on with x. Okay? And that's it. So that's vertical and horizontal translations. Okay? So make sure you practice these and understand how they work, because you'll be asked to do this on homework, exams and quizzes, and you have to be able to show your work, and we'll do some examples of that. Okay, until next time, have a great day.